Daily work unit 3.6. Tell whether the following is convex or concave. Now, here's the formal definition again. This particular polygon has this line, this side, that if we drew the line that contains that side, that line would contain points in here that are on the interior. That means that it is not concave. Concave is that no line that contains a side would contain points on the inside. None of the lines that contain this side contains points on the inside, so this is convex. The line that contains this side contains these points on the inside, therefore this one is concave. Notice again, a less formal definition would be that this one caves in right here, concave, and this one doesn't have any dents in it anywhere. In other words, it doesn't cave in anywhere. So we would say that it is convex, okay? So we have the formal and the informal definitions that we're using here, okay? Let's look at some of these. This says find the following for regular polygons with the number of sides given. So this is a 14-sided figure. We would call that a 14gon. To get the interior angle sum, you would take the number of sides, which is 14, minus 2 times 180 degrees is 12, so you would have 12 times 180 degrees, which would be 1800 plus 360, which is 2160 degrees. If you wanted to find each one, you would take that answer divided by the number of them, 12, and that would tell you each one, right? 2160 degrees divided by 12 would tell you each interior angle. The exterior angle sum is 360 degrees no matter how many sides it has. And if you wanted each one, you would take the number of them, 360, the interior angle sum 360 divided by the number of them, 12, and you would get degrees apiece for each exterior angle. Any questions on that? Explain why the exterior angle sum is always 360. And what you might want to do to think about that is to go back to the little chart. Notice as we think about each interior angle, what's actually happening. When we think about each exterior angle, what's actually happening. Therefore, what about the result? You need to kind of put that in words and think about that. Okay? We're going to let you do the rest of that chart. By observing the pattern at the right, explain what must be true before certain shapes can be interlocked to tile a floor. Notice that if we connect an octagon with another octagon with a square, then they'll interlock. You could tile a floor that way. Now, why does that work for an octagon and a square? And what you might want to think about is an interior angle of one and the other, and an exterior angle But what we really want to consider is the exterior angle of this one with the interior angle of this octagon, excuse me, with the interior angle of the square with the interior angle of the other octagon. See? So focus on that and try to put in words what must be true for those to interlock. Okay? More draw and label, and again, this is where I'm not going to do as many of these as far as teacher instruction. For my students in the classroom, I would model this. Hopefully, a teacher would be modeling this. Let me do some of this. It says a regular hexagon A, B, C, D, E with sides of length 18. Now, just to kind of get you going here a little bit, you would have a metric ruler, and you know the little marks like this are 1 centimeter and 2 centimeters. The 10 of those would be millimeters. A millimeter is about the width of a pencil lead. And so we would get 18 of those, which would be almost to 2 centimeters, and we'd make a segment. Now what we would have to do is use our interior angle of a polygon formula, number side 6 minus 2 times 180 divided by the number side 6. And you would have to get each angle and lay your protractor there to get your angles measured out. And then you'd have to take your ruler again and measure the sides correctly. And then you'd have to lay your protractor out and get your angle right. And then get your ruler out and measure 18 again. And then get your angles right with your protractor. And then get your ruler and measure again. And then hopefully when you get to the top, it comes out right. If it doesn't, you probably are human. And you got off just a little. Okay? It says the diagonals intersect to form an isosceles triangle. And it has some information there, so you can draw that as you go. So you can see that it really is going to make you think. Draw, label, create. Okay? So good luck with those. And again, teacher instruction in class will hopefully follow up on these things. And that's the end of 3-6 daily work.